Right.
Good morning, everyone, and happy holidays to the FAA world. Um, Welcome to the fourth webinar in our Red Hat FAA webinar series. Again, my name is Jonathan Beach, and I am the FAA Dedicated Solution Architect. And again, today we have another great webinar for you today, and we want to show the FAA world Red Hat Enterprise Linux. But before we get started, I want to go over some ground rules. By default, everyone's mic and video are muted. If you have a question that you want to be answered today, please enter it in the Q&A section of your window. From there, Jeff Thompson and I will be answering the questions as they come in. If we can't answer them, our presenter today will be taking pauses throughout the presentation to answer any additional questions. And at the end, we'll make sure we wrap up all the questions and get them answered for you. If there's something we can't answer today, we'll definitely follow up with you with an email. That said, I will put my email address in the chat. If there's any questions after the presentation, please feel free to always reach out to me, whether it's technical account. Jeff Thompson will be putting his email address in the chat as well. At the end of the presentation, we do record the presentations. We do post them in the DLT portal, as well as a copy of the slide deck. So by next week, you'll see both of those items in the DLT portal, as well as other webinars. So if you missed one, if you want to go back and watch it, please feel free to do that. I think that's all the items I wanted to cover. So today, like I said, we have Kevin Myers presenting. Kevin is the FAA dedicated technical account manager, specializing in the Red Hat platform technologies. Kevin will be giving us an excellent overview of Red Hat Enterprise Linux, along with some demonstrations. So I don't want to take up all the time today, so let me hand the mic over to Kevin, and go ahead, Kevin.
Hey, thanks, John. Thank you, and Jeff, thanks for helping set these up. So good morning, everybody out there. Hope everybody's surviving the snowstorm, wherever you may be on the East Coast, or if you missed it, come visit us out here and you can enjoy some of the snow. So like Jonathan mentioned, we're going to talk about RHEL today, kind of where we're at, where your operating system is at with RHEL, what you're getting with your subscription, and some of the new features I want to cover with RHEL 8, some of the pieces you may not be familiar with yet. So, let's just look at where we got to, where we're at now. Your operating system, I think, can be an overlooked component when it's working properly. We want to go back maybe 20 years. Linux and open source was really viewed as a threat to some of the platforms that had any market share in the data center. So you might remember one of our competitors at the time, called Linux a cancer. They were viewing it as threatened, and to now, where that has shifted to that same company now in many ways has actually embraced and supports Linux in their cloud offering. So our previous logo, now we have the red hat. You may remember Shadow Man, and that kind of identified that journey we took. At the time, Linux was this often found piece in the corner of your data center. It was running some of maybe your critical components, your web services, your DNS, and so a lot of times they might have been forgotten. That is until something crashed. But today, where we're at today, the shift is really occurring where we see more and more our workloads moving into the cloud. And it's not just public cloud. When we say cloud, so we're talking private and hybrid as well. And when we really look at cloud-based workloads, what we're seeing is enterprises are using Linux for the majority of those services in the cloud. So when we talk about RHEL, when we talk about Red Hat Enterprise Linux, really we're talking about a subscription. And there's advantages of this subscription. So what you're getting is you're getting access to our portal. You're getting access to insights, to the knowledge base, to labs we have online. So it's not just the technologies that are included in the distribution. So it's not just that base Linux, it's actually Linux Plus, if you will. So it's the distribution that includes all the open source packages. And we're also bundling in, identity management, IDM. You got Ansible, you got Podman now, all the container tools, app streams, all these things. We're going to touch on a lot of those today. It's also advocacy. Where Red Hat sits, we really have a history of involvement with upstream communities. So we're directly adding code. Some of our developers work full time almost, contributing code upstream to the open source projects. We have Linux user groups that we support. We also have that partner ecosystem. So we're bringing in partners and vendors to really give you a full-fledged experience. What this all translates to is you're going to save money, you're going to save time. So the tools we include, the support we offer is going to far outweigh if you were to maintain and package this yourself. Consider RHEL itself right now has over roughly 5,000 packages, and what it would take to maintain those in-house, not all 5,000, but whatever you need for your platform. A lot of work really goes into focusing on your infrastructure teams, your administrators, to make it easier for them to do their jobs. And we do that. We're looking at everything from Ansible, which Ansible is now included with RHEL, to the smart management features you get with Satellite. Recently, Insights was something we've added recently. It's a software as a service offering, and it's going to really complement what the administrator is doing. It's also going to help the manager out, that manager that needs to report on the state of their environment, where things are at. We also, don't lose focus, the developers kept in mind. So we have things like app streams. We're going to talk about those again a little bit later, but that's giving that developer, a broader selection to choose from within that same release. So this includes all the tools, the add-ons, so they can spend less time administering the system and more time developing. This was touched on actually a few weeks ago. Sebastian talked about what you're getting with your subscription, but just kind of a reminder where the FAA is at with your enterprise agreement is you have the ability to run RHEL on multiple public clouds. You don't need to go to a separate vendor and purchase yet another license or another entitlement. So this really brings that familiarity that your teams are going to get, whether they're running RHEL private cloud, whether they're public or hybrid, that combination of the two. And that gives you that same choice of operating system as long as you're using. Security, security is really one of these things. It's frequently in the headlines, and it's never in the headlines for a good reason. In fact, bringing this up, in the past week, we've really been seeing a lot of reports, from federal IT systems being compromised. I know with FAA, that's a huge concern. We want to make sure our systems are safe. Internally at Red Hat, we're looking at the aftermath of what recently happened, and we're analyzing this, and there's a lot of internal discussion. It's really reminding Red Hat, where do we fit in protecting our customers? Where do we fit in providing that secure, that reliable solution? Supply chain hacks are real. Supply chain compromises, are a real thing. We just saw that happen. And that's where we're just seeing that supply chain being such a critical piece for all the agencies to really look at, to consider when it comes to maintaining your security posture. What are you getting with RHEL then in sense of security? In terms of security, RHEL is common criteria level 4 certified. And to get there, Red Hat had to work with the U.S. government. We were BSI accredited labs. So everything was tested and validated for security, performance, and reliability. We are not only FIPS, so we talked about FIPS, we're not only FIPS compliant, but we have worked to become FIPS certified. So this is where, when you're certified, this is where we have an independent lab verifying our products, not just us saying, hey, take our word for it, we're FIPS. We've went that extra mile. We've got our products certified. Insights, again, I don't want to, there's a lot of pieces to cover here. So Insights is another tool that we have. It's going to help you scan, remediate. We're probably going to do a future webinar just on Insights, some pieces we can do there with things like OpenSCAP, but we just don't have enough time to kind of demo all of those pieces out today. But Insights is something, you combine that with OpenSCAP, really keeping your systems in tune to profiles. Also, we have Ansible to remediate, and this all just ties back into change control and reporting as well. Satellite, we had a webinar on that recently, a few weeks back. This is another item included in your ELA. It's going to help you better manage, going to help you better report, remediate through those updates and patches. So bottom line, when you're thinking RHEL, security is there, it has a strong presence, and that's really just going to continue to increase over time. Change, speaking of change, that's something that's always tough for organizations. Patching, updating, managing systems, it's a headache as it is. And I always felt that one of the more difficult tasks administrating and managing the systems, developers, and for the admins, we're just dealing with constant update planning, patch release cycles, and everything else. Anytime a new project would kick off, sometimes we were talking, some of your projects may project out 2, 3, 4 years. And when you're doing that, it's kind of looking, where is the base operating system going to be today, and what's it going to look like 4 years from now? So, because going between those major releases, it can, be involved at times. So what we have is, more of a set cadence. What we do now, we split our releases. We have minor or point releases. So for example, 7.8, 7.9. Now we're looking at, RHEL 8, 8.2, 8.3, so on. Each of these point releases, now when we're talking a point release, we're looking at a 2-year life cycle, and that's with extended update support. So what you're getting with that, if you want to stay at that specific point release that has the EOS, you could do so for the 2 years. And what you're getting in that is specific bug fixes, specific security updates. When you're moving, though, within a major release, it shouldn't be as scary as it once was. I know, if when I'm working with my customers, when I'm working with the accounts, it's always, what can we do to stay current? And if you're staying within that major release, it shouldn't really be as scary. So we have ABI compatibility, application binary interface compatibility. And that's one of the tested points. So generally speaking, the way that software interacted with the kernel on, let's say, RHEL 8.1, you should expect those same calls to work on RHEL 8.3. And again, once you get to 8.4, 8.5. So that's where we maintain that compatibility, that ABI compatibility within the major release. There's always some exceptions to the rule, and it's kind of really well beyond what we can go into here. But usually when we find those, they might be very specific issues, and we can leverage support engineering teams to work on a fix. But in general, staying within a major release should really not be as scary, especially now as it might have been a few years ago. So, I kind of hit on RHEL as a whole, but let's take a little bit deeper dive into RHEL 8 specifically. So a lot of you have made that transition from 6 to 7, and admittedly, that was probably rather drastic change for a lot of folks. I would say the biggest with that would have been your introduction to System D. With that came some learning curves, but really what you were left with overall should be a more stable and more efficient system. Should boot up faster, should be easier in the long run to actually support with more automation in mind. So now we're looking at RHEL 8, and again, there's a few changes, but we're actually seeing adoption handle these changes rather easily, rather reasonably. The platform stability is still there. We know change can be difficult. It can be disruptive. Change is disruptive. Change is expensive. Planning for that. And you already have limited resources. You have limited time, limited budget, limited staff. So now you're looking at training and all the features that come into the consideration. So to make that successful change, you have to have confidence in the skills, the tools needed to accomplish those tasks. And that's where, when we look at RHEL, we really see it as a platform that can be relied on to meet all of those needs. Not just the existing tools that can help you bridge those gaps, but it's also reducing the amount of downtime, the amount of change that's needed in the end. We're not just talking about OS redistribution. This is a full platform you build your services on. You can take advantage of all the innovations, multiple sources, limiting those disruptions to you. Beyond that, what I've tried to tell various customers, RHEL 7 is here today. It's in our maintenance phase right now. So what that means is no features are really going into RHEL 7. It should be considered a stable platform, and you have a few years left on RHEL 7. Nothing to be afraid of to stay there necessarily. If you're looking at a new project, maybe you want to start today on RHEL 8. Okay, RHEL 8 is still going to have new features. It's going to be added support for additional hardware, for instance. And RHEL 8 is where we're going to be on for at least that 10-year life cycle. And then again, RHEL 9 is something coming out next before long. So product teams are actually looking right now at RHEL 9. What does that mean for you? It means you have a stable platform. You're going to continue to have a stable platform on RHEL. The tooling is going to continue to be added, so you can transition between those versions with less pain points. There's going to be reduced time getting your applications into production. All right, so let's take a look. Some of the highlights of RHEL 8 at a glance. The kernel right now, this is where it all starts, right? This is version 4.18. And when we talk about that application binary interfaces and maintaining that compatibility across the life cycle, Okay, so that starts really with the kernel. So any changes we're making in that major release of RHEL is really including all of that compatibility testing. All of these core components are updated in 10 years. When we're talking a 10-year life cycle, that's a really, really long time for software. I mean, that's almost an eternity. So to keep this ABI, we really need to bring in a lot of these core components into this new baseline. And looking at this from community-driven open source software, it presents both solutions and challenges in doing so. What I mean is any change that we make really has to happen upstream first. And again, because this is open source software, it's community driven behind these projects. So the community can in some ways decide and shape the direction for the better. When we need to take an update then 3, 4, even 5 years after a particular kernel has been released, that can become a real challenge. So what we're doing is we're taking chunks of this code and more or less backporting certain fixes into this particular release. But in the end, being able to do that is really what has made RHEL so successful for businesses. Okay, for the developers, there's also app compatibility guides that we have out there. And those will go into more specifics on building software across releases. In addition, you can go to our customer portal, view the documentation there, and list out all of the limits and updates for the components. I'm going to go deeper into some of these new features in the presentations. Looking though at a glance at RHEL 8 and speaking specifically to FAA, what I kind of hear or what I heard over the past 6 months, 2 changes that I think stood out the most so far to most folks was Crony and Wayland. So just touching on those briefly, Crony is a drop-in replacement for NTP. It's actually more accurate at timekeeping, reflects some of the directional changes in the broader community. Overall, though, there's really not a lot of difference there from our support perspective. It's 100% supported. There are ways to get some other software to work, but that kind of skirts boundaries of support. So overall, you really shouldn't have many problems with Crony. Another one I get a lot of questions about right now is Wayland. So just to reiterate there with Wayland, X is not going away. In fact, X cannot go away right now with some of the proprietary drivers out there. So Wayland support is added, it's available, but there's really no forced change there across the board. All right. So looking at the intended life cycle, this is where we're intending to go. And I would say since we've kind of announced sticking to this cadence, it's been very close to occurring within this timetable. Cell phone companies would once say, you get a new phone every 2 years. We add a year to that. So every 3 years, we're looking at the next major RHEL release to drop. RHEL 8 went GA in May of 2019. So RHEL 9, by virtue would come out in May 2022. Alpha and some early release candidates we should be seeing within the next few months, actually. There are there's 2 major life cycles. There's full and then there's maintenance support. Full support is where we're at when we see, additional updates being added. That's where new features are coming out. That's where we're continuing to add new stuff, so to speak. Maintenance, though, is the other phase, and that's where the platform really just stabilizes. You're not really seeing many new features, but you will get bug fixes. You will get security updates. So overall, we kind of see these competing needs from customers. We have some that need those faster moving components to align with the software development, with hardware life cycles. They want to stay ahead. So they go to the new majors every 3 years. But then we have some that just don't quite have as much need for these features. So they tend to stay back. They enjoy those longer life cycles. So really it depends on what your needs are. If you want to maintain your faster moving apps on the latest, or if you need to stay within a release for the full 10 years, if you're more focused on stability, longer life of certain applications. But in the end, what we're really trying to bring to the customers is a predictable release cycle. So you can help plan your application, you can help plan your projects, you can help plan your programs and their impact by knowing when to expect the next version. Taking a closer look here, just looking at RHEL 8 then specifically. So right now we're kind of in this, we are in this full support phase, as you see these stair steps going across. And what that is, every 6 months then, we're dropping the next minor. And you'll see some of these have in the lighter blue here, this extended update support. And this is that add-on I was speaking about. And what that is it lets you stay on that minor for a full 2 years while you continue to get certain security updates, certain bug fixes, and whatnot without needing to jump to the next. So staying on an even release might be a target for some of you if you want to plan every 2 years to migrate across that. And then what we see up top, when we get after that 5 year, we get into the second phase of the life cycle, and that's the maintenance phase. And that's where, again, no features are coming out. It's perfectly fine to stay on this. As we're getting closer to 2029, of course, you want to start looking at going to RHEL 9. By then, RHEL 10 should be out. If we get into this latter half and you're still not quite ready for the next, we do have another paid add-on. Typically, we offer, and we should be offering it for 8. Obviously, it won't be announced until 2028. But what this add-on is, it's called ELS, Extended Life Phase. And really, what happens is you might have some systems that are just holding on. It really would be more expensive to upgrade them. You only have 8 months left on it. So you want to squeak out a few extra months of support. It doesn't give necessarily the same amount as EOS, but it does give you support offerings. It gives you a chance to call in, get critical bug patch fixes and the like there. So that's ELS, something with RHEL 8 we probably won't need to talk about for at least 8 more years, but just to know that is out there for those apps you just can't get rid of. All right, so some of the newer features in RHEL 8, a lot of exciting things that we're seeing here, application streams. And I want to talk about this first. So what application streams offer is it gives us more versions of some of our common tools and frameworks. They're going to be available more frequently. What happened previously was you may have had to stay, let's use PostgreSQL in this example here. RHEL 7 came out with Postgres 9.6. RHEL 8 drops with 10. So what you can do is with an application stream, you can still run that Postgres 9.6 on RHEL 8 when you're ready and jump over to Postgres 10. Looking ahead, when 12 becomes stable, that'll be a choice as well. So looking at this visually, you're going to see your major versions of RHEL down here, but then where the app streams line up, they may not fit on those boundaries. So what we're doing is just being able to offer an additional stream to get these different versions out there. The benefit of the application stream. So these packages, they will install at the standard expected location, okay? This is pretty big, so it's going to be easier for your users, for your administrators to find and use that app. The flip side from that is only one version may be installed on the system at a time. So you have some use cases where you might need multiple versions are required. We're really thinking that's where containerized versions of the streams offer a better overall solution. And that does overall align with kind of the direction of where things are headed overall. These also contrast with software collections. You may remember those from RHEL 7. This is now a single repository, standard package names, standard install locations. So there's no need to kind of enable those collections. You might remember doing the SCL enable, getting some wrappers, everything around using the collection that kind of made it a little more challenging to work with than we would have liked. So this, again, by having this repo, these streams, and by using the modular functionality now of application package management, we can offer these multiple versions of collections now within the single repo. So you're going to get faster access to these. You're going to spend less time searching for upstream, searching, compiling them all yourself, kind of jumping ahead, jumping around, only have to do it again every time you patch and stuff. So it really just balances out some of those features with the stability support you need. Just a note, though, on the application streams. So do check as you're using these, the life cycle, as a support. Some of it does vary slightly from the core RHEL. The best bet for that is when you're using an app stream for the older ones, for the older streams, take a look at the customer portal, see what's available, see the life cycle for that there. One other change so you're going to see with the app streams, and actually you're going to see overall with the repositories is how they've been collapsed down. In RHEL 7, we've had, what do we have, extras. We had software collections, .NET Dev Tools. All of these now coexist within the app stream. Like this one repository, it's still delivering that same release cadence, multiple package versions that we want to provide. but we end up with fewer common sets of repositories across all of the products variants. So it's really going to make things easier for you, and it actually makes it easier for us as well to package and maintain. One of the complaints we would have a lot more from users, they had problems understanding, what software was available to a system, and a lot of times that would lead to us, we'd get RFEs published and work around just to move packages, the same package variant around between different repos. So starting with RHEL 8, you're going to see that. And in addition, what you're going to see is this base OS down here. Previously, we had server, we had workstation, we had HPC, and now they all use this base OS, the same set of packages and the same repositories. And I'm going to talk in a few minutes, a few slides ahead about system roles as well. But just to reiterate here that base OS is now the same for everything. Okay, there's no more separate base for server, a separate base repo for workstation, just one common repo across the board. And we kind of visually see that here. Again, the bottom box now representing the RHEL 8 repository structure. And up here, you'd see what we had before, or what we still have with RHEL 7. Okay, for server specifically, we have a separate base for workstation. Okay, so that becomes simplified. One of the takeaways for this, though, to remember is there are two core repositories, so base OS and AppStream, to enable those at all times. Keep that in mind. So if you're not using satellite, you're performing some manual repo syncs, keep these two available to your systems. You're also going to see some minor changes to Yum. I'm going to get into those in a little bit. But the takeaway, again, just take away reduced number of repos. It's going to be easier to manage. It's going to eliminate a lot of these confusions, questions around what's extras, what's optional. There is one other repo over here on the right in the darker red here. That's the Code-Ready Linux Builder. This is where build dependencies are moving out of from optional. So Code-Ready is actually a brand from our development group. It's a marketing brand at Red Hat. And these are for those customers that you're building applications against RHEL development libraries, primarily with maybe C, Python, Ruby libs. It's very developer focused, again, on setting up that system, getting it quickly moving from deploying that system to start writing code, developing code. One other note, I just want to point out, we still ship the third-party proprietary packages in supplementary, so that still exists here. Nothing has changed for that, and that should still exist for the rest of the RHEL 8 lifecycle. So DNF, Dandified Yum. This is actually Yum version 4. This moves us from Yum to DNF. It's actually, under the hood, you'll still just type in the Yum commands like you did before. Don't get scared about this. Be excited about it, because what it is, this is actually a complete rewrite. It is compatible still with all the APIs, all the commands you would use previously. So the RHEL Yum 3 stack should continue to work as you expected it with the DNF-based tool. So that means any of your scripts, you had the scripts, kind of homegrown tools that were referencing Yum, those should still be fine. Although if you are using homegrown scripts, just going to put a plug in, Ansible might be something to look at there. So what this also adds a new feature. So we have module support now for those app streams. The API is actually all new in this, but it still has crossover. The biggest limitation you might find, and I haven't come across any of our customers that have done this yet, but if you did write any custom Yum plugins, it's been pretty rare again, but that's about the only limitation that we may, that we foresee could be a problem. Again, most customers do not write Yum plugins. I've yet to come across, in all my experience, coworkers that have either. So I'm pretty confident you'll be okay there. What else do we offer here? So some of the separate packages you used to install Yum utils, those are now available as subcommands right from Yum 4 or DNF. So things like repo query, the download local, all of that stuff. There's no need to add additional packages. It's all included now. Yum 4, actually, the lines of code was cut almost in half. So it's much more streamlined. Other plugins you might have used before, fastest mirror, priorities, transaction flags, all of that stuff is just native functionality. The other thing, really what this gives is faster resolution for dependencies. So it's going to give you actually a better experience, faster overall, and it's still going to be familiar. So we're not saying, switch to a whole nother package management system. Most of the time, you won't even know anything changed. It's just going to be faster, more stable in the long run. All right, so we talked briefly about insights. I want to kind of switch gears and take a closer look at that through our slides here. It's important to know that your subscription to RHEL includes insights. So any supported version of RHEL that has access to the Red Hat Insights client, so that's RHEL 6.4 and above. It's not just a RHEL 8 feature anymore either. So it's no longer just a RHEL feature anymore either, excuse me. So multiple products have insights rules. And I really want to drive this home though. Your RHEL subscription today, what you're getting with that enterprise license is you're getting access to insights. You can start using almost everything I'm talking to you about during this session right after the call. So what is Insights? Insights is going to give you intelligence. It's going to start analyzing your RHEL portfolio across either your hybrid or your on-premise infrastructure. It can interface with satellites you may have already set up today. And it can work directly as a software as a service offering if your systems can connect to it from where they sit. So when we look at the fit of Insights, there's two key use cases. The operational efficiency. And this is where Insights can help identify problems, quickly develop remediation plans for them. Several of the identified and known issues use Insights actually have Ansible plays. We have templates for those plays already built from within Insights. So you can use Insights to download a play specific to your system. Quickly, you can run that remediation and get back to whatever you're doing the rest of that day. This also fits for security, for risk management. So when we talk about focus on compliance, remediation, vulnerabilities reporting, it's all within Insights. And let's just take a quick look at a screenshot of the dashboard. So this is, if you've used Insights before, take a look again. This has been updated and it continues to get updated. So this is the more current Insights interface, and you can see, hopefully you'll see if you've used it before, there's several new services out there, and it actually does continue to be expanded upon. So from a support perspective, our teams continue to look at repeatable patterns that are discovered from user-reported problems, from customer-reported problems. So we actually update our knowledge base frequently, but in addition to that, now we're looking at Insights rules. So if we have 20 customers or 30 customers reporting the same problem with a certain aspect of the product, whether it's a configuration issue, whether it's who knows what, we're leveraging Insights now to be able to share that knowledge and come up with predictive analytics to help resolve this burden, to help lessen this burden on the administrators. As managers, so Insights isn't just for the admins, it's also for managers as well. So we can get quicker access to the data, to the key metrics about our systems. So whether we want to find maybe is a system missing a security fix, or do we have a configuration that drifted from a policy, it really reduces that time spent collecting the data and gets you back to work quicker. Again, this is really something I know we don't have a lot of time for today. It would probably take a full hour, or we may even split it up into multiple webinars in the future. But where we can actually do some live demos, and I think we're going to dive into that in a future webinar series. But overall, there's a few Insight services I just kind of want to look at from here. Initially, Insights was actually a single service, and Insights really has expanded. So when it continues to expand, it's now a family of services. So they're all complementary to each other, and they're going to help you with some of those key use cases, the operational efficiency, as well as the security, the compliance, and the risk management. At a glance then, so looking across all those, we have Advisor. And what Advisor does is Advisor is going to highlight the availability, the performance, stability risks, and it's going to do that based on recommendations from support experiences. So those cases I talked about where we're looking across a broad spectrum of all the cases, we find common issues, that's where we can use Advisor to build these rules. So somebody already found an issue, we share that, we lessen the time. So still going to be some known issues, best practice, knowledge base gets published, but now we've just added this to that mix of what it takes to help the customers out. Vulnerability service, this is where we can do assessments, and you can report on your Red Hat Enterprise Linux, your common vulnerabilities and exposures, the CVE. This is actually frequently requested by security teams at customer sites. At a glance, your security team may want to know what systems do we have that are a vulnerability, that are vulnerable to a known attack. we still see zero-day attacks out there, zero-day exploits. So security teams may want to know very quickly what is vulnerable to that. And as soon as we would get it updated in Insights, you can run a report, you can find that out. Also, not every fix might be implemented right away. So some of those CVEs may have other mitigation techniques that are just as effective as long as you know what systems are impacted. And that's where being able to report on those vulnerabilities is almost or is just as important in many times as fixing them. The compliance piece, this is where we're assessing, where we're monitoring for regulatory compliance. This is actually built on OpenSCAP. So that's the open source implementation of SCAP standard. Security posture, it's really more than just ensuring patches are applied. It's taking that specific configuration that you've worked with your security team to help develop, to ensure your systems are compliant, all of that. And the best part is, I know I've mentioned this a few times, but there's Ansible plays that can actually be generated to help get your systems back in line to SCAP. Drift, again, when we're looking at Drift, we're enabling you to create baselines to compare your systems against those profiles, either the baselines or other systems. And then with policies, maybe you don't want full SCAP or you have needs that are not addressed by SCAP. And this is where policies come in. So these Insight policies, they let you define, they let you monitor against your own policies to kind of identify anything that's out of whack, anything misaligned, needing to be sure, for instance, let's say you want all of your systems to have a firewall. Let's say you want all of your systems to have disk encryption software installed. So that's where those policies come in and allow you to do that. And lastly, there's the patch service, and this analyzes your systems for any Red Hat specific product advisories that are for your specific systems particularly. So it helps you know what is needed, it helps you stay up to date, it helps you plan ahead. To take an outage to patch, it's always good to know what is going to be applied versus just running that yum update. So this is where the patch system will help. You can report on it. It's also part of good housekeeping. You may have a requirement to keep systems patched on a certain date or level. So it's just really, that patch tool helps you do that, keep everything up to date, and get that analyzed. So there's one other piece. It's not really directly part of Insights, but I know we mentioned it in this service. It's Red Hat customers have asked for Subscription Watch, and that's something, we can talk a little bit more with the FAA. I know with the ELA, there's some questions with that. I'm going to defer that to the account team at some point, but Subscription Watch is there, and that's another tool to help kind of track your subscription usage. Especially, you have an enterprise agreement, so you can consume all you want with RHEL, but you might want to see where are those subscriptions being used, and that's where Subscription Watch comes into play. So, 3 steps if you're interested in Insights and you haven't used it yet. Really there's 3 steps for it. The first, you want to register your host with Insights. So this can be done individually, or you can actually scale this out through Smart Management with Satellite, or with Ansible Automation Platform to get them registered. You do need access. Your system will need access to the cloud. Access it. Once it's registered, though, go out to the Insights portal. Go to cloud.redhat.com. You can log in there. You can review any findings. You can create reports. Review, prioritize what is found, and then finally, the remediation. It's great to get a report, but if you're not doing anything with it, it's really not helping. So remediate. You prioritize what you want fixed. You can follow step-by-step instructions on how to fix it, or in many cases, again, let it create the Ansible playbook for you to help automate those remediation steps, get back to what you want to do quicker. If you are a Satellite user, the steps here are slightly altered. Satellite is what will communicate with Insights instead. So this kind of eliminates some of that need for your systems to connect directly across the internet to the Insights. John, I'm about halfway. Did we have any questions or anything we wanted to pause for before jumping into the next?
We just did get a question from Patrick. We do have a few other questions, but I'm going to follow up with John after the meeting.
Okay.
But Patrick asks, does Insights offer a solution for application whitelisting?
Application whitelisting. we'll get some more details on that, on what we're looking for there. For it depends on which insight service, I guess. If we're talking about creating an SCAP profile where we can make an approved list for what apps are approved or in policies. So yeah, we can talk more about that, get a little more specifics, and kind of see what we're looking at there. But yes, everything, maybe it'll answer the question. It is rather customizable. So this isn't necessarily Red Hat saying, here's a one-size-fits-all solution. It's more or less Red Hat saying, here's a tool you can use and customize to meet your particular needs for your systems, and then do those scans against them. So that's kind of where Insights is at.
Okay, Patrick, we'll follow up with an email after this conversation. That's all we have, Kevin. Go ahead.
Thanks. So Image Builder. So this is another new feature you're going to see here. This was previously known as Composer. So with any virtual environment, the creation and management of images is really a key operational concern. It's part of that life cycle of your app environment, your program team, whatever. So the concept here, the concept behind this is it's getting better control over what packages are installed. And compared with, starting from our vendor supplied image, what customers want to see is really consistency across that different development footprint. So you're ensuring that your security, operational excellence, application support is all met. So what you can do with this, you can build your images from source RPMs. They're deployable to multiple targets quickly and simply. It provides also, you get finer grain control, I should say. You get more visibility into what's included in that image. You get its history. You can view the whole history. You can check in that blueprint. You can view the change of that blueprint from inception to current and everything else. So it kind of answers some of those challenges. Where did this image get built from? What updates need to apply to it from today? You view what gold images are out there. How do I consistently deploy these images with the appropriate packages across multiple environments? So there's 3 steps to this overall. You're going to start with basically a list of packages. You create a configuration, then you combine that into an image, and that's what the Image Builder does for you. You can then take these, and it's infrastructure as code. You can check them into your code repository, watch it over time. Once the blueprint is created there. Using Image Builder, so you can use Image Builder from Cockpit, from the web, from command line. There's also some GUIs that will help you out with this. System roles. Okay, so I may have mentioned the word Ansible a few times. I think Ansible, really Ansible has matured where we're at with the whole DevOps model with configuration management. So this, I think, was one of the big moves forward. Just where we're seeing configuration management over the past decade to where it's just now so integral to our systems. We had the previous demo on Ansible. Key takeaways were really, solve your challenge once, solve your problem once, build it out, and create that repeatable method for the future. So with system roles, what you're getting is part of this automated environment. RHEL provides roles that are basically native hooks, and they're going to allow that configuration to be assisted in managing the platform. So these system roles, they allow you to configure all of your systems using Ansible. So basically, it's going to speed up that process. You're going to take advantage of these pre-written tasks, pre-written handlers and modules. And these roles, they provide that layer of abstraction, if you will, at the automation level. So now we have this common syntax across multiple versions of RHEL. For instance, looking back across various releases, we have that nasty word change again, but to simplify this, let's use the networking role to configure an interface, for instance. We can now no longer have to write a separate playbook to handle init scripts in RHEL 6 and for Network Manager in RHEL 8. So with the roles, with the networking roles that provided, we can use that same role, writing the same set of tasks, and it'll basically work between 6 and 7. You don't have to worry about all the intricate details because the role is going to handle that. So in the end, we can quickly configure the core components of these systems. We don't have to, again, hit each task. We don't have to hit each series of tasks and differentiate between the major releases. These are provided. They're quickly dropped into your plays for the admins. It's really going to help reduce their workload. So just looking at this here, we have on the left, these are our various roles. Provided system roles are in red. We also have, you can write your own roles. So this is not only what Red Hat provides. We also provide a framework and instructions on how to create the roles. They can be combined, mixed, matched, and really, just help set up your system as needed. In this example, in the slide here, 3 roles are selected. They're combined into a single playbook, and then those 3 roles are applied to the system. And it really helps reduce that friction, that cost of change. So you're having a repeatable process. And when we look at DevOps, automation is really a cornerstone of that. So it's using that infrastructure as code. It's taking all your configs to be written. They're going to be version controlled. They're going to be compared through changes throughout the life cycle of your system. And Ansible just helps integrate all that with a build chain. So you have this entire process now that's kind of automated from system inception all the way through the finish of this. One other piece, I'm not going to hit on this one too much, but I do want to kind of highlight it and maybe a point of interest. So RHEL 8 will actually run MS SQL Server, so Microsoft SQL Server. We actually have a partnership with Microsoft. We even have insight rules that can help find stability or performance issues when running SQL Server on RHEL. So really, you still have that wide range of open source databases, but just throwing this out there, some customers have found a need for a new platform to run MS SQL Server on, and that's Linux can be that platform of choice. We talked, again, hardware partners. This really aligns with your workloads. So your Linux OS works on several hardware platforms in addition to running in the cloud. You can always check what is supported. Check out catalog.redhat.com, where you can browse that full list of certified platforms along with our products. If it's not listed, it doesn't mean it won't work. But what the catalog does list is there's certified platforms, really, where we have this established partnership with these vendors, and that partnership allows us to provide device support, feature updates, kernel modules, all of that specific to their hardware products. Again, just repeating earlier, your RHEL sub, you can use it on several public clouds, no extra cost. You still pay your cloud provider for whatever compute, network, storage you consume from them, but this allows you to leverage your existing license under the ELA. And really, it gives you that full range of choice. So where heavily focused is hybrid cloud, which is this mix of public-private cloud. And by allowing you to run RHEL across that, it just gives you that consistent experience. It's your own data center, you can use a public cloud, you're getting the same tools, you're using the same Ansible, you're using the same satellite, all of those pieces that you're familiar with. You don't need to learn separate tools for separate clouds. Okay, containers. So RHEL 8 and containers, this is really where we start to see this full set of container rules right from the initial GA release. It's not only the tooling that's provided in RHEL, but containers are just fundamentally a new way to address, we're taking advantage of existing Linux kernel capabilities. And these capabilities are added into the Linux kernel now. So it's not some other project you need to add. It's not additional packages, not additional daemons you need to run. It's all in the kernel now. Plus, when you're looking inside of the container, what's inside of that container is also Linux. Okay, so the actual applications themselves, these get built, they're built using the dependencies from the platform. But now we have this ability to better separate the dependencies on how the application is built from how the application accesses these resources. So really, in the end, what that does is that makes your container very transportable from one host to another. You put the dependencies inside the container, let the host that container runs on determine and worry about what resources are needed. So it just really becomes a fundamental shift in worrying less about the dependencies on your tool chains or your libraries within your server at large. And now with RHEL, you can run these traditional applications, still need it, but you have this added support to start adopting containers. You don't need to move to all containers yet. but you don't need to move to another future operating system when you can do containers and your traditional apps right here. This portability really also helps with, we eliminate that whole, well, it worked on dev, not on prod. So you can start to eliminate that by having that portable container across the life cycles there. And also, with RHEL, we start seeing that we're setting the stage for orchestration and scaling. So where your project might eventually go with OpenShift as it gets larger and needs those extra features, those containers can happen now, or they can happen in the future. So just looking at our slide here, we have the bottom red blocks, and these are, the operating system capabilities. We're combining these to create the Linux containers within our gray blocks up top. And these are really the concepts that are provided by the container engine. And it's not just that, but they're actually baked into the kernel more so now than ever. So again, we're talking about adopting containerized workloads. We still see, what we're still seeing is real world adoption may lag behind some of that hype. If we think back, let's just think back years ago. Running virtual machines, it was, running a VM was okay for dev and test, but it really took time to get to that point where production was trusted to run on a VM. And now we just see less and less. I see very few actual workloads running on physical systems. We're virtualizing that, we're slicing that up. This is really that next progression now. So we're taking that application, and instead of adding a complete virtualized OS underneath it, we're moving that application around now as this containerized image. And we're still seeing at various stages across the customer base how they're adopting it. Containers are inherently more complex than a VM for understanding that relationship they have between the components, between the application, the dependent resources, and how it all ties together to make it work. But the takeaway I want you guys to understand from this is, RHEL 8, it just powers this entire Red Hat hybrid cloud portfolio. So underneath everything from the tooling, the development of containers within the OS, we have CoreOS, we got RHEL-based worker nodes and OpenShift deployment. So if you think about that moving down the road, moving to OpenShift, underneath you still have the same RHEL footprint to what you can use today to start your container journey. So if you're not ready for OpenShift yet, for instance, you can start running those containers today, and talk about some of those tools that make that up. Podman. So Podman is this tool where you can design, you can build, you can run, you can manage all your containers and images right from the command line. No need for a separate daemon to start running. So looking at the stack of this, we have your container image on your system storage, and then you have Podman right above that. Okay, and Podman, that's the actual container engine. So here's the piece, it just manages the images, it runs containers using the run C above the stack. This tool is really where we can build the images from standard input files. And not only that, we can put them on system storage. The run C layer, this is that lower level container, that runtime, and that's what that creates those namespaces, okay, those kernel calls. So what you don't see here between Podman and run C that we've had with other products is that's where you have additional daemons. So Podman is going straight to run C, and then run C takes that and goes right into the kernel. So that's where we mentioned earlier. The Linux kernel really is what has the capabilities to support all of these container features. And then on top of the kernel is where these containers are actually running. They're secured, they're isolated, they have access to the OS resources they need through the kernel. Okay, so the nice thing about Podman as well, we can actually build these images, we can push and pull them from registries, we can manage them on disk, we can create them, we can label them. All of those typical operations you need to manage those containers can be done on this single host. And we're also talking rootless now, okay? So there is no intervening daemon. There's, Podman, it can actually use user namespace isolation, so we can support these non-root operations on containers. And what that means, it allows the root user within the container to be mapped to a non-privileged user outside the container. So no need to escalate. You don't need to give everybody and their brother root anymore. You can do that now. This really, this was designed, so Podman was designed. It is a drop-in replacement for most of the existing workflows that might use Docker tools. No extra repositories to enable, no extra daemons to start, nothing extra like that. Just install it and go. Um, we also have, we can export and import our pod definitions in standard Kubernetes format. So we talk about pods. So a pod is a group of basically one or more containers that share the same network, they share the same PID process, identifiers, inter-process communications, IPC namespaces, all that. Again, what this allows really is this easier transition across the portfolio journey is what Podman adds. So some key takeaways: no daemons. You got improved security and tracing with that. Standards-based operations and outputs. You're eliminating some of the complexities, some of the tie-ins. So we also have Builda. Okay, it sounds like I guess a Boston term, Builda, like chowder. But in addition to Podman, this adds additional tooling. It's a way to create and manipulate these images, really with a high degree of control over the sources used. So tools used to install packages and files. We can layer all the metadata within the final image. When we talk about doing everything with automation in mind, this is really where Builda starts to come in to play. So here we have this container image build tool. It's designed with that automation in mind from the ground up. And the result is we're using a host-based build tool like this. Final content of the image is not just dependencies for the application. There's no additional OS tooling, no additional package management. Everything is in there. So you can create a working container with it, install the packages into it using Yum from the host. So we're eliminating that complexity at runtime where it needs to compress that down. Okay. When we look at this today, we have the typical, kind of the multi-layer today. We're creating everything from the base image. We're adding a new layer for the OS updates, new layer for maybe our Java runtime, and then the actual application. And this, from scratch, compresses this down into a single layer. So the last kind of piece of the container tools that we have in RHEL is Scopio. Okay, so you have your container images, they're built, they can be stored in a registry, or maybe you build it on this host, but you need to move it and share it to another host. And this is where Scopio comes into play. It provides that greater level of control over moving and inspecting these images. It allows you to inspect. Actually, you don't even need to download the full image to the host. So you can look right through the metadata for Scopio, things like the version, creation dates, all the other information about that image can be pulled and analyzed right from the registry directly. It's designed, so it'll handle the transport of images from different storage locations on the host. So publishing, pulling from the registry, remotely copying between the registries, all of that can be done through the Scopio tool. And this really gives you more degrees of control over sharing these images as well as publishing, the lifecycle promotion, and whatnot. So visually what this looks like, either the metadata signatures or even pulling from your local repository. What happens is, we still have this connection to remote registries, whether that's Red Hat branded one or whether, whatever your registry is. All right, so, okay. Firewall management, security, always a hot topic. You may be familiar, so with NF tables, RHEL 7.6 onward, I believe we had it in tech preview somewhere around RHEL 7.3, but regardless, we had all of these tables framework, IP tables, IP6 tables, ARP tables. Some of these overlapped, other times we get these bad chains that kind of put us into an undesirable state. So NF tables is as a default, it really brings a more flexible framework for our firewall rules into RHEL 8. This is built from the NetFilter project, supports IPv4, IPv6, ARP, bridge rules, all that in a single framework. Okay, we can address families and we can help eliminate redundancy of having all of the separate frameworks, so to speak. So it's also giving third-party tools is another thing. So intrusion prevention systems, we can help manage dynamic firewall rules. So you might have an IPS system that wants to hook in. NF tables kind of gives that functionality. So we can throw up rules on the fly. It's atomic. They're atomic in how they get modified. So that eliminates some of the race conditions that can happen between multiple updates. multiple actions. We can also combine multiple actions into a single rule with expressions. So we have a little more flexibility in matching allows and denies. What it means in the end is, we have improved tracing capabilities. We have simpler debugging of the rules, and the ultimate verdict on whether a package is allowed, denied, or dropped happens quicker. With the new backend, so Firewall D is no longer required to have complete control over the firewall. So this kind of removes that potential contention where services that didn't previously support Firewall D, that's removed. It also means, if we're flushing firewall rules, it's only going to apply Firewall D's NFT rules. So it helps remove some of those scenarios where custom rules would basically get unexpectedly removed. Talking about the atomic nature of the rule updates, this also eliminates some of those rule change from IP tables, rule sets where they could fail, kind of leave your firewall basically in a bad state. But multiple actions are now combined into a single rule. So we eliminate that need then for specific rules, for instance, just for logging or jumping to another chain. We still have the concept of chains, and what chains are, they're sets of rules. Then we have tables, which are sets of chains. Multiple tables can be still evaluated, but in the end, better integration with third-party IPS, better integration with other tools that want to create and manage our firewall rules. Overall, just wrapping up security. I know we're going to have a future security webinar series, but it really needs to be at the forefront, I guess. I just don't want to see FAA in the news. Cyber attack, cyber terror is really a new forefront of some of these. So it's a scary possibility. When we talk security, though, security is, in essence, it's an ongoing process. It's not really an end state. I'm sure you've heard that before, but technology just changes too fast for security to be an end state. When we're talking about RHEL, security happens at multiple levels. And it's really about having this operating system with security design that's in mind that can help streamline that whole process. So what RHEL does is, we have this highly secureable platform in cloud infrastructures. It's for emerging workloads like machine learning. It's the basis for cloud platforms like OpenShift. We've talked over some of the tooling, and we're going to continue to get into that more. But with RHEL, what you have is you have the controls you need to quickly, consistently secure your environment, minimize your attack surface. Red Hat, we also have a product security team, and with this team, it's not really a feature, but it's more, I would say, a key benefit of your subscription, and that relationship you're going to form with Red Hat. This team, they're not focused just on security fixes. So this team is not just going out there writing the fixes, but they also take into the consideration, the impact of that and the risk, the remediation efforts that it takes. So when you see it and we're describing the mitigation, all the remediations, how does that impact your system? Sometimes can the fix be worse than the problem? And so this group, what they really do is they work with our partners. They're tracking vulnerabilities. They're tracking patches available. This group is also, creating rules for insights, so we can highlight critical security issues, critical risks there. At the end, it's all designed to make it easier for admins, for system owners to implement these controls to make your systems more secure. Another hidden benefit of that is the code analysis and review that engineers are doing as part of their regular work. So RHEL is a software product. During its development lifecycle, we do static analysis just like any other security-oriented development team would. Additional work may be required to pursue certification. So specific sectors like DoD. What happens is when these certifications are achieved, it's really spin-offs. The spin-offs of getting those certifications is going to give general improvements to all of our RHEL customers. RHEL also introduces a few new protocols. So we now have TLS 1.3. There's also non-backportable libraries. So OpenSSL 1.1.1. We can't necessarily backport all of this to RHEL 7 without potentially breaking some of the apps there. So staying on these more current majors is going to increase that. Looking ahead, FIPS 140-3, that's in the pipeline. Again, we're pursuing certification there. So it's not just compliance. I mean, anybody can claim compliance, but we're getting that certification. So we have that trusted third party that's going to analyze these claims and ensure we're doing what we say we are. All right, so I know we're getting close on time. I do want to talk about this, at least the cockpit. Um, I actually like this feature. I like a lot of features, but this is one I'm not going to lie. I was actually personally a little hesitant about it first, uh, after having used previous web-based administration tools in the past. Really, where this comes into play, we talk about this move to DevOps. We talk about self-service environments in larger organizations. And suddenly we end up with application administrators, we end up with developers, even line of business users, and they're in some ways being asked to manage their own RHEL systems. IT has always been stretched thin. We don't have the staffing to do everything we need to do. Um, so there's more and more systems now. IT is really managing that orchestration and the availability of those systems. So we also have this rise in public cloud. So Linux use has been driven across the board. We have migrations away from other GUI-based operating systems, and suddenly we have these admins that are in unfamiliar territory. They're on a new operating system. It looks different. The command line can be very scary for folks. Okay, so what we have here with Cockpit, we have a more familiar view to help troubleshoot and fix your systems. It means they're going to be more comfortable when asked or even mandated to start using Linux. We want it to be less scary. We want it to be easier. We want it to be quicker for all the admins to use. So, and it's not only for what I'm describing as maybe the new admin, even experienced admins. This web console, it's going to provide it does provide a consolidated window so you can start performing tasks that would normally require several different command line tools, all with different syntax, all with different command line options. Managing storage, for example, we can see in this screen here, it suddenly becomes easier to actually visualize it. The ordering sequence, PV create, VG create, LV create, all that stuff. Example, it's really reduced down now into a single viewable screen all in one place. We're not jumping between tools. And what I really like about this that kind of sold me on it is changes made through this web console are going to use the native methods in RHEL. So it's not like some previous tools where you had to be very careful of either using the tool or not. There is no separate configuration state that gets created. So the web console, really it just brings that simpler view for the new user, consolidates tasks, and it really helps make it easier as well for the experienced user. Some features that are new in the web console. So one other goal with it is, we want to remove some of those X11-based system management tools and provide that common continuous experience. So virtual machine management, Virt Manager, can be done now through this. Network-bound disk encryption, so Lux devices, again, with a more visual setup. Auto-config of things like your Kerberos authentication, joining a domain. Everything is in your web console. Performance Copilot, log analysis. So more and more is getting added to this, to Cockpit. And again, it's using underneath, it's going to create and use the same methods that you would do if you were using the command line. Okay, so the SPY, the T-log, this is where you can, this is a feature, share with you guys. There's two main audiences for this one, actually, when we're looking at it. This is recording user sessions, and there's two main audiences for that. So from a security, from a regulatory requirement, as well as those that are looking to facilitate training, documenting procedures. So there's kind of two separate use cases, but what we see a lot, so the T-log, the terminal log can capture user input, program output. It'll even, if you resize your window, okay. The logs that it generates, they're integrated, so they're integrated with your system logs, more centralized, easier review of that. If you have security requirements for auditing, this is oftentimes in place if you need to audit your admins or your users. This allows that recording and playing back of the session. So we get much more certainty when we're categorizing user actions. We can improve separation of responsibilities better. We can even better detect inside threats now by analyzing the logs of that session that it creates. The logging itself, so it can be done via SSSD. It can be triggered for all users. We can be granular to specific groups of users. We also mentioned, so I mentioned the training and demo. For those cases, you don't need SSSD. You can just spawn this dynamically. and then use either system logs or dump it out to a specific alternate file. And then playback's going to be available from the command line or, again, the web console. All right, so the last piece I'm going to touch on today is called LEAP. So this has actually been, LEAP has been one of these requests for these in-place upgrades. There's really a tremendous amount of work to kind of get this product out there and available where it's at today. And what LEAP aims to do is to provide this seamless, non-disruptive migration process for your existing deployments. So RHEL 8 kind of enhances that migration process by introducing this. What the LEAP tool does is it's going to analyze your system. If it detects any problems, it's going to create a report so you can address that. And it's going to perform that actual upgrade. It's going to do that. It's going to reboot, move that to an in-memory image. It's going to update it, and then you also have this LVM snapshot you can fall back on. Right now, we're essentially, I would say, kind of version 1.0 of LEAP. It's that initial release. So there are some scenarios that I know have been kind of problematic. They are getting enhanced. I definitely see LEAP from RHEL 8 to 9 having many, many, many more features than we have now. Right now, it is there for RHEL 7. I know there's some use cases at FAA specifically that we've kind of run into. We're kind of stuck. In particular, we're in this transition from FIPS 140-2 to 140-3. So we're kind of hitting some roadblocks there, but the bottom line, it is available. Some of your systems may support it. It's a general workflow. You pick your server, create your snapshot to run LEAP against, analyze it. If there's anything that needs fixed, fix it. Otherwise, you're going to reboot, let the upgrade run, and complete. And then you still kind of have this snapshot you can fall back on. So the alignment to that basically is, LEAP is there. It's coming. We know in-place upgrades. Common feature asked about, so that is there, and that'll continue to grow. All right, so hope I didn't talk too fast. I tried to squeeze everything in, and there's certainly more topics we want to get out and drill into more specifically. So, John, do we have time for any other questions or comments?
Sure. We do have a question from Joel. If you want to go back to the app streams. His question is, what is the intended meaning of AppStream? I followed the overview of the package management, but wanted to get a second opinion on this. I did notice when I set up repos for CentOS, I had to enable the base repo and the AppStream to resolve an error.
Which slide are we back on here? This one?
The app streams, is that, I think, yeah, I was going to say that one. Or that one.
Yeah, so when you're setting up, did you say the question was about repo sync?
No, so what's the intended meaning of app streams?
Okay, so app streams, basically the intent of the app streams is, the true intent is basically, if we're looking at our release lifecycle, you'll see RHEL 7, during the RHEL 7 cycle, just using this diagram here, Postgres 9.6 was out. Postgres 10 kind of came out so late in it, we couldn't include it. You want to go to 8, we're going to ship 8 with 10, but maybe you need to drop back to 9.6. So really, app streams, the intent of the app streams is to give you more control over which version of those applications you're running on that intended release. So it's to make it easier. The comparison I would give, software collections, we had that with RHEL 7. Software collections didn't come without its overhead. You'd have to, SCL enable different versions and everything else. With app streams, you can much easier go to a specific version of these packages and not have to worry as much about compatibility issues.
Thanks, Kevin. Joel, we'll follow up after this call and make sure we answered it. And if we didn't, we'll definitely be able to answer it for you a little bit better via email.
Yeah, and some of this too, there may be specific use cases or more specific details, and we could certainly set up some one-on-one calls or just check-in calls with different groups to go over those where that makes sense.
Okay, but that's all the questions that we currently have. I don't know if you have anything else or.
I don't. I know we went a little bit over. Um,
That's okay.
and so,
Okay.
but yeah, we'll definitely.
Go ahead.
Yeah, go ahead, Jonathan. I was just going to say, I do want to wish everybody, happy holidays coming up here. I do look forward to having some additional engagements with all of the teams here that we can go over some of those features more in depth. Thank you.
Thank you, Kevin. So, yep, like I said earlier, we'll definitely follow up with everybody about the questions you had. Make sure we answer them correctly. If you have any more questions, you get a couple of requests for meetings, so I'll schedule those as well. I wanted to take the time to thank a few people that made today's webinar happen. Obviously, first, Kevin, great. Thank you so much for showing us Red Hat Enterprise Linux today. As always, thank you, Jeff Thompson, for taking the lead to make this happen today. Also, our partners, CDW and DLT, for taking the time to help us send out invites, create the invites, update the portal, as well as doing some back-end work after updating this in a few days. We do greatly appreciate everyone's work. I will take a quick second to plug our next webinar, the first one for 2021, which will be on Red Hat OpenShift. I know that is a hot topic nowadays. It will be a high-level overview, sort of like today's was, and there'll be follow-up webinars after that that go into some details of OpenShift. So from myself and the rest of the Red Hat account team, I would like to wish everyone a happy and safe holiday, and we'll talk again in 2021. Thanks, everyone. Happy holidays.
See you guys.